Hello everyone, welcome back to the post-contest discussion session series, and we will be discussing today starters 157, and we will be taking the first 6 questions of Division 4 today. So beginning with the first question itself. So here is the first question. The question says that chef is buying spectacles and he's deciding on which frame to purchase. And chef has narrowed his options down to the two of the following choices. Either he will buy a plastic frame which costs X rupees, or he will buy a metal frame which costs Y rupees. And chef will buy the metal frame if and only if uh, the metal frame costs at most twice the price of the plastic frame. Okay. Otherwise, he will buy the plastic frame. Okay. So you have to tell whether chef will buy which frame. Okay. You have to print plastic if he buys a plastic frame. Else, you have to print metal if he buys a metal frame. So the input is like you are given with two values, X and Y. X is the cost of plastic frame and Y is the cost of metal frame, right? So the condition for buying metal frame is that if the cost of metal frame is less than, which is at most two times the cost of plastic frame, right? Which is X here, which is X here. So if this thing holds, basically, then chef is going to buy a metal frame or else he will buy a plastic frame, right? I hope the explanation is clear. Let's see the implementation. Implementation is also quite easy. We will take these two values inputs here, X and Y, and then we will check if Y is less than equals to twice of X, which I have explained here, uh, right? Just a second. Which I explained here. If Y is less than equals to 2 times X, then we will take a metallic frame. Else, we will take a plastic frame, right? So that was all for this question. Let's move to the second question. The second question says that Alice and Bob invented a brand new algorithm, but they can't decide what to name it. And Alice suggested that SA should be the name of the algorithm, and Bob suggested that SB should be the name of the algorithm. And however, Alice thinks that Bob's name sense is really bad, and she'll be only happy if the name given to the algorithm is not close to SB at all. More specifically, Alice will be happy if and only if the algorithm's name does not share any characters with SB. Similarly, Bob also thinks that Alice's name does not make any sense, that is, it is really bad, and he'll be happy only if the basically both the strings SA and SB don't share a common character. So then either of the players will be happy. So is there a way to name the algorithm so that you can make both Alice and Bob happy or not? So you have to print a yes if you can make happy both of the guys, and if you can't, you have to simply print a no. So as the intuition says, or it is like very quite clear that you are basically given with two strings, SA and SB. Okay. So SA is the name suggested by Alice, basically for the new algorithm, and SB is the name suggested by Bob for the new algorithm. And Alice does not wants to SA to anyhow resemble to SB. That is, by resemble, uh, I mean that SA, like any character in SA, basically, if I have to say like this, should not be equals to any character in SB, right? So if this thing happens, then Alice would be happy and also Bob would be happy, right? This, if I iterate over all the characters, like this is for all the characters, all the characters C in both the strings, SA and SB, SA and SB. So this was like regarding the pseudocode, but what I am trying to basically say is that Bob named it SA and Alice, sorry, Alice named it SA and Bob named it SB. and Alice wants that SA should not be closer to any, should not hold any resemblance to SB, and Bob wants that SB should not hold any resemblance to SA. That means that if there is any character which is not present in SA and SB, right? So that means that you can choose that character in naming uh, your new algorithm, right? So basically, if I were to say it like this, that let's take an example. If let's say Bob names the new algorithm, sorry, Alice names the new algorithm says A, B, C, D, and Bob names is that B, D, E, right? So there are two characters in common. Okay, there is a B in common, D in common, right? So you have to like give the algorithm a new name such that no character is common with SA and SB itself. So what you can do is you can I see that if like there are only 26 characters, right, at max. So if there is a character out of these 26 characters which is not present in SA and SB as well, then that character can be used for naming the new algorithm. Okay, so likewise, it is going to satisfy the either of the conditions. Like Alice would also be satisfied and Bob will also be satisfied. So just we have just to check that if there is a character out of 26 characters which we have in our alphabets. So if there exists any character which is not present in A as well as not in B, right? So for the implementation of this same thing, we can just see that I have taken the test cases here, and in the test cases, we are given with N and M, which are the respective lengths of string S and T. So I have taken SA in S and SB in T. So after taking the inputs here, well, I have taken a vector which is going to tell me it is of like length 26, okay, and it stores that if uh, if a character has been visited or not, okay. It simply means that what I will do, I will just iterate over the strings. Okay, I will iterate over this string S, and I will see that whether this character, like what I will do, I will just simply mark this character visited in my flag array, and similarly I will do it for T. So what will happen? So actually, what happens is that all the characters, all the characters collectively in SA and SB gets marked in flag value. Like okay, let me explain it here. What I'm doing is uh, I have SA and I have SB, right? So there would be some characters in SB and there would be some characters in SB. And if I take union of them, right? If I do it something like this, so there will be some like there were X characters here and Y characters here. So there will be um, some characters which would be obviously like less than equals to X plus Y, right? There will be a count of characters Z such that it is less than equals to X plus Y. So in like all those characters which are combinedly present in SA and SB, those all will be visited, right? So if there is any character left out of those 26 characters which has not been visited yet, like in SA and SB, then I can safely say that that character can be used in renaming my new algorithm such that the condition is satisfied for both, right? I hope it makes sense. So the same thing I'm implementing here, that I have taken a flag. It just marks that if a character is visited or not. That is either it is present in SA or SB, or maybe it is present in both. So what I will do, I will just simply do a flag of I minus A. So what it is like, it is basically an index. Like I will be a character. Okay. And if I subtract it from A, so what will happen? Like the ASCII value gets subtracted, right? The ASCII value of small alphabets, or like the lowercase alphabets, goes from A to Z, goes from 97 to 122, right? So when I do I minus a, so basically what happens is whatever this I is a character, let's say I is E. So the ASCII value of E and A gets subtracted and you get the index basically. So each character from A to Z will be having a unique index, and that would be from 0 to 25, right? In that's why I have taken an array of size 26, and thus you can maintain the visited vector here. And you can see, like, while iterating this visiting vector, I have checked the condition that if I is 0, that means that if there is any character which has not been visited, I can simply print a yes. That means I can safely rename that algorithm, right? And I can mark my flag as false here, and I can safely break out of this. And if anyhow, like this condition is not satisfied, the flag remains true throughout, and then I'll simply print a no, right? So I hope I'm very clear with the explanation. So the next question says that you were given a binary string s of length n, and you can perform the following two-step operations on that string, and you can basically, what are the two operations? The two operations are, you can choose a non-empty contiguous substring of s, and if the substring contains an odd number of ones, you can delete every zero in it. And if it contains an even number of ones, you can delete every one in it. Okay. And finally, you can do it any number of times, and you have to perform this two-step operation as many times as you like, and you have to find the minimum possible length of the final string. Okay. So let me once summarize the problem statement. The problem statement is simple. The problem statement says that you will be given a binary string. Okay. You will be given a binary string s. Let's assume that this is your binary string. Okay. The problem says that if you choose a substring out of this, and let's choose a substring. Okay. Let's choose this 101. If I choose this substring, then it says that if the count of 1 in this substring is even, okay, then you will delete all the occurrences of 1 in this substring, and you will like place it back in the original uh, string, right? That means that this string would be reduced to 1. These ones would be deleted, and 0, and these two zeros. Okay. So this would be the operation. And I had mm, had I chosen this substring. Okay. So this substring is 11010. Okay. So it contains odd number of ones, right? So if your substring contain odd number of ones, then you can delete all the zeros in the substring, right? So you will delete this zero and this zero, this zero and this zero, and ultimately your string would be reduced to 111 and a zero. Right? These two zeros would be deleted, and this zero would remain. So our goal is to, like, you can do these operations any number of times, and you have to reduce the string. So let us talk about a case where my string is going to have all zeros. Okay, let's see this. My string is going to contain all zeros, right? Can you reduce the length of the string? Can you, like, the count of one here is, like, if you were to look upon the whole string as the substring, then the count of one is zero, right? That is an even number. And for an even number, you can only delete the ones present in the substring or the string, right? You cannot delete a zero. So for such a scenario where all zeros are present in the string, now where not even a single one is present, you cannot reduce the length of the string, right? Why? Because you cannot delete a zero if there are even number of zeros, if there are even number of ones in the substring, right? You cannot reduce. Okay. So this is one case where you cannot reduce the string. Else, if there is if there is at least uh, at least count of 1 is 1, that means at least one occurrence of 1 is there in the binary string, then always it is possible to reduce the size of the string somehow, either to 0 or 1. Okay, how it is possible? Okay, so if the count of 1 in the string is greater than equals to 1, this simply means that either there will be odd occurrences of 1 in total, or there would be even occurrences of 1 in total. Okay, so let us discuss the case first where there are odd occurrences of 1 in total. Okay, let's take a fair example. Let's assume there were some zeros here. Okay, there was a 1 here, some zeros here again, and the number of zeros here which I'm leaving the blank spaces, it could be any number of zeros. Okay, could be 0 also. Like the number of zeros could be 0 also. I'm taking all the possible cases where the count of all the possible strings where the count of 1 can be odd. Okay, so it is like 1 here and again any number of zeros, and a 1 here and again any number of zeros. Okay, so let's suppose my binary string used to seem like this. Okay, these blank spaces signify any number of zeros could be here. Okay, any number of zeros. So if I were to delete these zeros, okay, what I will do, I just need one I just need odd occurrences of 1 to be present in my substring, and I can safely delete all the zeros. So greedily, if I want to delete these many zeros, so what I will do, I will choose this my substring. So what happens is all these zeros gets deleted, and this 1 remains. Okay. Similarly, these zeros can also be deleted by choosing this substring. By choosing this substring, these zeros can be deleted, and by choosing this substring, these zeros can be deleted. So it compresses my strings to my string final string to nothing but 1, 1, and a 1. Okay, that means that only 3 ones would be left in my final string. And if I choose this whole string as a substring, which means that there are odd number of ones, so it will reduce my string again to a what? Um, if there are odd number of ones left, right? So what I can do, if I have to delete ones, so I have only one choice, that I choose a string with even length. So I will choose a substring which contains of elements n minus 1 out of this, n being the current size of the string. So what it will do, it will release all the ones present here, and I would only be left with a single one. Okay. So this is the strategy what I will deal with if there are odd occurrences of 1% here. Yeah. I hope I'm clear with this case. Let's see the case where I have a count of 1 as even. Okay, where count of 1 is even and greater than 0, right? I have dealt with the case where the count of 1 is 0. You can't reduce the size of the string in such a case. So when the count of 1 is even, there would be a similar case that some zeros are 1, some zeros are 1, some zeros are 1, some zeros are 1, and again some zeros. So similarly, what I have told you, that if you want to delete these zeros, you can pair up them, or you can basically group them with a substring having only single one. Okay, you can like group them up like this. So what happens is this, like in this substring, in each of the circles, these represents a substring. In every substring, what is the scenario? There are any number of zeros, there are any number of zeros, and there is a single one. That means there is odd number of ones, and in such a scenario, all the zeros would be deleted, and you would be left with nothing, just that one in the substring. And there you will get another one, there you will get another one, and another one from here. Right? So you would be left with nothing but all ones, and those all ones would be of even length, right? And then again, if you choose whole string as a substring, then the case would be of even ones, and all those ones get deleted, and you left with nothing. That is a null string of length 0, right? If I have to summarize this whole thing, you just have to look upon the case where count of 1 is 0. Count of 1 is 0, nothing can be done. So you can't reduce the length of the string, should be n. If count of 1 is greater than 0 but odd, okay? And if it is even, if it is odd, then you have to print, you can reduce it to a size 1, and else you can reduce it to a size 0. These are the three cases which can be like classified. So let's see the solution here. Let's see my submission directly. Okay. Here what I'm doing is I'm basically taking the input here. I've taken n as input here and the string, the binary string as input here. Okay. After I've taken the input, I will try to find the count of 1. Okay. So I have iterated over the binary string. If the current character is 1, I will do a count plus plus. It is basically showing the count of ones in my string. That count is 0, nothing can be done. I will just simply print an n. Basically, the value of length cannot be reduced, and I will return from here. Else, if the count is odd, then I will print a 1, else I'll print a 0. Okay, so it was quite easy. Let's see the next problem. The problem says that basically this is the easier version of the problem. The easier version of the problem says that AI is less than equals to 2. Okay, either it is a 1 or it is a 2. Okay, and it is saying that you are given an array B and it is said to be normal. Okay, it is said to be normal if its mean is equal to the median. Okay, so this mean and median is defined here, and you are given an array basically consisting of n integers, each of which lies between 1 and 2, and then you have to count the number of contiguous subarrays which are normal, right? So um, the problem says that you would be given basically with an array. Okay, you would be given with an array such that for the easier version, I'm saying that array consists of either a 1 or a 2. Okay, it would be of length n. The array would be of length n, and it would be either containing a 1 or a 2. Okay. Now, now the now you have to tell the number of subarrays in the problem, the number of subarrays which are normal. And how a normal subarray is defined? A normal array is defined, or a normal subarray is defined as a subarray such that the mean of that subarray, let's take that subarray as B. Okay, the mean of B is equal to the median of B. Okay, I hope you are clear with what is a median and what is a mean. Okay, so mean is basically, let's assume that your subarray looked like 1 to 1, and so basically for mean what you will do, you will do 1 plus 2 plus 1 divided by the length of the subarray, that is 3. So you will land upon 4 upon 3, which is nothing but 1, right? So, and uh, that would be nothing but 1.33 actually, to be very specific. And uh, for median, you have to sort the subarray. For if you sort the subarray, you will be left with 112, and then you have to pick the middle element. That would be your median. So median comes out to be 1 here, which is not equal to 1.33, of course. So this is not going to work. That means that median is not equals to mean here, right? Median is not equals to mean. Okay. So this problem would have been a more difficult one if the constraint was not applied here. The constraint which is applied, that AI consists of only one or two, that this makes these problems are quite easier. Let me show you how it makes it easy. So let us assume a scenario where let us try to find that when mean can be equal to median. Okay, when mean can be equals to median. So I want to say that if you consider a subarray where all elements are equal, let's say those elements are x. Okay, there are n number of x's present there. So what would be the sum of the array? It would be nothing but x plus x plus x plus x n times. It would be sum up to nx, right? And if I divided it with the count of the elements, which would be nothing but n, so it is going to mean that the mean of the subarray comes out to be x, right? And if you are going to sort it, it would be nothing but in the same fashion, comma x comma x, such till like n times, right? So the median would be nothing but x again, right? Because if all the elements are x, the median would be obviously x, right? So this means that if all the elements are equal, if all the elements are equal in any subarray, so that is the subarray where you can safely say that mean is equals to a median, right? Okay. And now if you were to have a look upon your question, now your question says that your array is going to contain just a one or a two. Okay. So what happens is if your array contains what? If your array contains a arbitrary number of ones followed by arbitrary number of zeros followed by arbitrary number of ones, basically a random arrangement of some ones and some sorts of twos. Let it be like 2 1 2 1 1. Okay, this is your subarray. What would be the mean? Mean would be 2 plus 2 4 and 3 7. 7 divided by number of elements, which is 5. And if I were to sort this array, it would be triple one and 2 2, and the median would come out to be 1, right? Median would be 1. So a important thing to notice here is if the elements if the elements are like my AI is just 1 or a 2, my median could be nothing but a 1 or a 2 itself, right? Either it will be a 1 or it will be a 2. Yes or no? I hope this makes sense. If there were more number of twos here, like if there were three number of twos and two number of ones, the array would be like double one and triple two. It would seem like this. And then in this scenario, my median would have been 2. Uh, hmm, Median would have been 2 here, right? So I want to say that if median is 2 here, so when can my mean result into 2? Okay, what I'm trying to say is there are three elements, basically 2 here, so it comes out 2 by 6 plus uh, plus some uh, these two values. Okay, let it be some x and some y, and if the count of number of elements is 5, so if I want this to be a 2, so this would be nothing but x plus y equals to 4. This comes out to be this. Okay, and it is clear that this value can be only satisfied when x equals to y equals to 2. Cannot be satisfied with any other combination of 1 or 2 except for 2 and 2, right? Can you see this thing? Yes, I hope this makes sense. So it simply means that if median is a 2 and you want mean also be 2, this reduces to a only case where median and mean both are 2 is that all the elements present in the array should be equals to 2, right? So this is the case where if all the elements are equals to 2, this is the case that that subarray is going to have mean equals to median, and that is equals to 2. Let's talk about the median when it is 1. So it would be a case where number of ones are greater than number of twos, right? So let's assume there were 3 ones and some two number of twos. Okay, there were two twos. So here median is 1 and I want mean to be 1. If I want mean to be 1, then it would sum up to like 1 plus 1 plus 1. And let's say I replace these values with x and y. Again, would be nothing but 3 plus x plus y divided by 5 equals to 1. And this reduces my equation to x plus y equals to 2. And if x and y are non-zero values, then this case can only be satisfied when x equals to 1 and y equals to 1, right? Can you see the exclusivity of both the cases, right? So this whole thing basically sums up or basically gives an intuition that answer is only possible in this case when what I mean by answer is only possible that mean equals to median. Okay, so mean equals to median is only possible when you choose any subarray, but condition is that when all the elements all the elements in that subarray are equal. All elements in that subarray are equal, right? This is the only case when the answer or the answer can exist, or basically the subarray can be normal. Okay, for a subarray to be normal, that is mean equals to median. This is the only case when all the elements in the subarray are equal, then the subarray can be said to be a normal. Now you have just left with the task that you have to count the number of such subarrays, and subarrays are contiguous, right? So all the subarrays with size 1 can be counted, right? Because only subarray with element 1 is uh, having median as 1 and mean as 1, and 2 same for 2. So if the count is 1, uh, basically the size is 1 of subarray, so the answer exists. That means that these subarrays are normal. And what else we can see? We just have to see that in the given array, if there is a segment where contiguous twos or contiguous ones are present. Okay, if your array looks like 1 1 2 2 2 1 2 1. Okay, so this is your array. So so we will divide it into segments, right? Like these are the segments. I'm dividing it into segments where uh, number of elements are same. Basically, the adjacent elements are same. Basically, a groups of two, a pair of one, here a one itself, and a two. I have divided it into these segments. Okay. Now, how many possible sub-arrays can be there for an array? Is it can be calculated by a simple formula that if there is an array of size n, then the total number of sub-arrays possible for this array is nothing but n into n plus 1 by 2, right? So if I were to look upon these segments as individual arrays, so this means that there is an array consisting of two ones, right? Consisting of two ones where all the elements are ones basically, and its length is 2. So how many subarrays could be possible out of this array of size 2? It would be 2 into 3 by 2. That would be 3. And if you were to see that what are those three subarrays, that would be nothing but these all would be the subarrays of size 1. It would be 1, 1, and 1, 1. So these are the possible subarrays can be made out of this array. Okay. So this is the number of subarrays, and all these subarrays are normal. Yes or no? All these subarrays are normal. Why? Because all the elements in the array were equal. So if you were to take any subarray out of this array, any size, it is going to be normal, right? So you can count all the subarrays of an array such that all the elements in that array are equal. So I have divided my original array in two segments which are having contiguous number of elements which are basically adjacent and they are equal. Okay. If you divide it like this, counting would be easy. Like uh, this is an array of length 2, which basically contains all ones. This is an array of length 3, which basically contains all twos. This is an array of length 1, which basically contains all ones. Similarly, all twos and all ones. If you were to like divide your array into such segments, then counting would be easy. You can say that k into k plus 1 by 2 would be the number of subarrays for any array of length k, right? So far this is the whole explanation for this problem. So it became quite easier because it was reduced to only two elements, 1 and 2. Okay. I hope I'm clear with the explanation. Let's see the implementation as well. Okay. So let's see the implementation. The implementation, we have a quite cleaner code here. So I have taken the test cases here, and then I have taken the inputs here. Okay. I have taken the length of the array and array itself. I have taken the array itself here input. And what I have to do, I will just um, initialize my answer with 0, basically the count of arrays, and a length with 1. Why length with 1? Because at least you will having mm, at least the minimum length you can have of a subarray is 1, right? So that's why I have initialized length with 1. And what I will do, I will iterate over all the elements, or like iterate over my array, and I will see if ARR of I was equal to my previous element in the array, then I will do a length plus plus. Basically, I am trying to find the length of the contiguous blocks or the contiguous segments which have same elements, right? So when I will be moving into a else part. That means that adjacent elements are not equal. What I will do, the length I have so far, I will try to find the number of subarrays which were possible out of the length, right? And I will initialize my length again with 1 because I have broken this condition here. So I will initialize the case with length equals to 1, and in my answer I will add these many subarrays. Okay, add these many subarrays in my answer, and ultimately I will simply print my answer. That was the solution for this. I hope I'm clear with my solution. Okay, so let's move to the final and last problem we will be taken into our discussion. So the problem name is Unmedian, and this problem says that you are given an array of length n, and you can perform the following operation on it. So you can basically choose a contiguous subarray A of length greater than 1, and that has to be of length odd, right? And then you can delete the median of this subarray from that. Okay. And if there are multiple occurrences of the median, you can delete the leftmost median. And this thing decreases the size of the array by 1, of course. It is possible to perform this operation several number of times, so the final array is sorted in non-decreasing order. Okay. If it is possible to anyhow sort the array basically, so you just have to tell that is it possible to like following these operations any number of times. So is it possible to sort the array in not non-decreasing order? And if it is possible, also you have to find a valid sequence of operations which you will do to get that array into a sorted array. So let us take an example here. 3, 4, 1 and 4, 5. Let me explain you the problem once. So the problem statement says that you would be given with an array A. Okay, you would be given with this array, and what uh, what you have to do is you have to basically sort this array somehow. Okay, using an operation. And what that operation is you can choose a subarray. You can choose a subarray of length greater than 1 and odd. Okay, of length greater than 1 and odd. Okay, you can choose any subarray, such subarray, and then you can uh, you can delete the you can delete the median, right? You can delete the median of the subarray from this array. Okay, and that too, if there are multiple occurrences of median, then you have to delete the leftmost median, right? So you can delete the median only once, मतलब, only once in single operation. Okay, but you can perform the operation any number of times, so it does not matter. So you would be left with the you have to delete the leftmost median, right? So let's take an example. Basically, 3, 4, 1 and 4, 5. Okay. So array looks like 3, 4, 1, 4, 5. So I have to see that hmm, if I can make this array sorted or not. Like what I can do, I can choose a sub-array of length greater than 1 and odd. That is the minimum size of sub-array chosen possible is 3. No sub-array of size less than 3 could be chosen, right? So if I were to choose this sub-array, what I will do, I will find out the median. For finding out the median, I will sort the sub-array. It would be 1, 4, 4. The median comes out to be 4, right? So what I will do, I will delete 4. But which 4 would be deleted? This or this? Leftmost would be deleted, right? So I will delete this 4 with my original array, and I will be left with 3, 1, 4, 5 as my final array. Is this array sorted? No. This array is not sorted. Again, I will do the operation. So again, choose a subarray of size 3 because of size 4 cannot be chosen. Nothing with less than size 3 can be chosen, right? So I will sort this 1, 3, and 4. The median comes out to be 3. I will delete a 3. Okay. I will be left with 1, 4, and 5. Is this array sorted now? Yes. This array is sorted. So this is the problem statement basically which it is asking us to do. It is asking us to do whether there exists a sequence of operations in which you operate that you will be left with an array which is sorted. If you cannot sort the array anyhow, then you have to print a -1. Else you have to print that sequence of operations. Okay, that sequence of operations. So let us try to look upon this problem. So let's see on some observations. Like I had an observation that obviously it is like not an observation, but it is quite clear that any subarray of size less than 3 cannot be chosen, right? So if I were to reduce my array, like, okay, operating once on the array reduces my size, right? So if I were to do this operation any number of times, let's say I do it n number of times, okay, any number of times, n can be anything. After performing it for n number of times, if I am left with an array which is of size less than 3. Okay. Either I'm left with two elements or I'm left with a single element. Okay. In such a scenario, nothing can be done, right? I cannot reduce this further if I'm left with only one element or if I'm left with only two elements. Why? Because subarray has to be of a size minimum at least 3, right? I cannot further reduce this. So this simply means that if on a broader perspective, like if after doing any number of operations, if the array becomes sorted anyhow, like in the previous case we were looking like here, it becomes sorted, became 1, 4, and 5, right? It became 1, 4, and 5. Can I further reduce it? Although the demand is over that the array is sorted, but just for my happiness, I want to further reduce it. I will reduce it to 4 and 5. Like the median would come out to be 4. Okay, 4 would be deleted. It would be now 1 and 5. Why I am reducing it? Because I want to generalize. What I want to generalize is that two elements are left here, and this cannot be reduced further. So that means that after performing any number of operations, either I will be left with two values or a single value. Okay, so a single value is sorted in itself. So whether it is possible to sort an array or it is not possible to sort an array, in either of the cases, I will be landing upon the same page. That is, either I can reduce the array to only two elements or a single element. So, uh, continuing on this thought process, I thought that if I thought that I thought that if there were if there were if there were two values and out of those two values, the left one was like there were two values left and right. The left one was less than equal to the right one. Then the array is sorted. And if there is only one value, then it is sorted anyhow. Okay. So I don't care about this case. I just have to look upon the case where I have two values. So if I can reduce my array to two values, but I have to like keenly or greedily reduce my array into two such values such that I am left with this scenario. At L is less than equal to R anyhow. Okay. If this scenario happens, then I can safely say that my array can be sorted and then I can basically find out the sequence of operations. Okay, so keep this thing in mind. And meanwhile, let me tell you another observation here is um, like if you were to look upon subarray where you find a median. Okay, let's say this is element A. Like this is in sorted order. Okay, consider it is in sorted order. A1, A2, and A3. If this is in a sorted order, then what is the median of this subarray? It is A2, right? So I can safely say that what I can safely say that hmm, that the minimum element of any subarray is less than equal to the median of that subarray, right? Can I say this thing safely? If, if A1 was equals to A2 was equals to A3, if this was the case, then A2 would be the median, and this thing is again going to hold, right? So this thing is going to hold in any of the scenarios. So I can safely say that minimum is less than equals to median for any subarray. Now, if this was the case that all those three values were equal, I would be deleting A2, which is nothing but an occurrence of X. If these all three were equal to X, which is nothing but occurrence of X or the minimum value. Like there were three occurrences of minimum values, and you are basically going to delete A1, not A2. Why? Because A1 is the leftmost occurrence of X. A1 is the all I'm talking about the case where all these three values are equal. Okay. A1 is the leftmost occurrence of X. So basically, you will be deleting that occurrence in that subarray uh, where basically this is basically the leftmost occurrence of uh, minimum value. Okay, so inference we can derive from this is that in a broader perspective, in either of the scenarios, in all the scenarios, basically the rightmost occurrence, okay, the rightmost occurrence of minimum value, let's call it as mn, okay, mn is going to persist, okay, that means it is going to persist, it is never going to be deleted, never. Why? Because a3 here is the rightmost occurrence of that minimum value, right? Similarly, if I were to look up on a broader perspective, like this was my array, and the min value of the array had this as my rightmost occurrence. So no matter you choose any subarray, whether this includes this element or not, this is never going to be deleted, never, right? Like I have shown this here, this is never going to be deleted. So I can apply the same thing on a broader perspective that the rightmost occurrence of the minimum value of an array is never going to be deleted, and it is always going to be like always persist, right? Similarly, you can apply the same logic on the max element also. The max element of the array is always greater than equals to the median, right? It is always greater than equals to the median. So that means that if all elements were equal, that means the max was equals to x. In this case, where a1 equals to a2 equals to 3, a3. So max is x. And similarly, this a1 is going to be deleted if we were talking about the occurrence. So similarly, we can say that the rightmost occurrence, the of rightmost occurrence of max in an array is going to remain. It is going to persist, right? So with these two observations, I can conclude what I can conclude that ultimately, the two elements which are going to survive, which are when I'm reducing my whole array into these two elements, so I can safely say that these two elements would be nothing but one would be a minimum value and other would be a maximum value, right? I have like clearly shown you why this is happening because the rightmost occurrence of minimum is never going to be deleted, and similarly, the rightmost occurrence of maximum is never going to be deleted, right? So, with this thought process, you can safely say that if you are going to reduce your array, okay, this array is given to you, and if you are going to reduce this array into just two elements, so those two elements would be nothing but one would be the minimum element and another would be the maximum element. Okay, so you don't need to basically reduce it uh, for real. You can just simply see what you can simply see. You can simply see that the rightmost occurrence, okay, the rightmost occurrence of minimum value mn and of maximum value mx. The rightmost occurrence of minimum value is, let's say, x, okay, and this is the index basically, the occurrence, the rightmost occurrence, okay, this is index in the array, and the index of the rightmost occurrence of mx is y. This is y, okay. So I can safely say that if if x was less than equals to y, then obviously when I'm going to attain those two values, when I'm going to reduce my array into two values, obviously minimum would be placed on the left side and maximum would be placed on the right side. Yes. So I can safely say that if x is less than equals to y, that means that array can be sorted. Else, if x is greater than y, that means that minimum would be placed after the max value in this scenario, and array cannot be sorted anyhow. Okay. So now we are just left with like the sequence of operations. Sequence of operations. So this is no big deal. Why? Because if there were n elements in an array, okay, if there are n elements in an array, and I want to reduce it only to two elements. So how many number of operations in the worst case scenario I need to perform is n minus two, right? And what can be those n minus two elements operations? I don't care about the operation. Why? Because I know ultimately those two elements would be nothing but a min value and a max value. Okay. So no matter in any order I perform these operations, I would be landing on the same page. Okay. So these n minus 2 operations would be performed. And I can always safely choose a sub-array size of 3. That is the minimum size. And what can be the indexes? The indexes could be 1 and 3, right? If you keep on repeating these operations n minus 2 times, you would land upon the same page. That is, you would be left with two values, and uh, those would be the minimum value of the array and the maximum value of the array, and their relative order is the only thing which matters here. Okay, so I hope I'm able to express the explanation of this. And if there is any doubt, you can feel free to unmute and you can ask. Okay, and meanwhile, we can see the implementation also. We have a clear implementation here. Implementation is quite simple. Like I have taken the test cases input here, and after the test cases, I have taken the vector here. Okay, the array is taken as input here. So what I am trying to do, I am trying to calculate here position minimum and position maximum in the array. And min is the minimum element and max is the maximum element, initialized with 1e9 here and a 0 here. Okay, so I will iterate over the array. I will take the array, the input ai, and then I will see that if min is greater than or equal to ai, that means that there exists a more lesser value in my array. So I will update my minimum and I will also update the position. Similarly, basically what I'm trying to do here is I'm trying to do the find the rightmost occurrence of minimum value in the array and rightmost occurrence of the maximum value in the array. If the rightmost occurrence of the minimum value is less than equal to the rightmost occurrence of the maximum value, I can simply print the sequence of operation. That means this simply means that array can be sorted. Else the array cannot be sorted, so I will print a -1. And in the sequence of operations, there is no big deal printing the sequence of operations. It could be you can print the number of operations as n-2, and always you can print this as your operation. The left index is 1 and the right index is 3. Okay. So I hope I'm clear with the explanation part. So that was all for this time. Okay. Thank you for being here. Okay.